Hello, are you taking Praxis Elementary Education Mathematics Subtest 5003, Geometry and Measurement, Data, Statistics, and Probability? If so, then this is the video for you. Hi, my name is Tom, and I am a test prep expert here at Study.com and a former math teacher, and I'm going to walk you through some of the types of problems you may see on the test. So let's get started. Problem 1. What is the volume of a piece of solid aluminum if it has a mass of 8.1 grams and the density of solid aluminum is 2.7 grams per centimeter cubed? In this problem here, we're dealing with a mass density volume problem. So what we're going to use is we're going to use this visual, the mass volume density triangle, which gives us the operations that we're going to need in order to make this calculation. So at this point in elementary school, the students haven't done algebra manipulation of formulas. So what we want to do is we want to give them a visual to help them solve a problem like this. And in order to use the visual, we need to identify what information that we have. So in this case here, we're given that the mass is 8.1 grams, and we're given that the density is 2.7 grams per centimeter cubed. In order to use the triangle, we want to identify what we're trying to find. So in this case here, we are trying to find the volume. So what we do is we go to our triangle and we cover up volume. So we just cover that up, and we can see in the triangle that the formula for volume is, after we cover that up, we have mass divided by density. So what we're going to do is we're going to take our mass, and it says the mass is 8.1 grams. We're going to divide that by the density, and the density is 2.7 grams per centimeter cubed. And if we do that calculation, again, we'll have our online calculator. In order to do this, we're going to get our answer of 3 cubic centimeters. Problem 2. Which statement is true about this platonic solid? This is an octahedron which is composed of 2 tetrahedrons. This is a tetrahedron which is composed of 2 pyramids. This is an octahedron which is composed of 2 pyramids. This is a pyramid which is composed of 2 octahedrons. All right, so the first thing we want to help students identify is octahedron and tetrahedron. Octa means 8 in math, and tetra means 4. All right, so when I identify the solid, I want to see how many faces it has. So if we look at this and we counted the faces, it would have 1, 2, and then it has 2 hidden sides. So it would have 4 faces on the top and 4 faces on the bottom. So I know this must be an octahedron, okay? So I know I'm going to eliminate these 2 choices here. Now, we need to identify, is it composed of 2 tetrahedrons or is it composed of 2 pyramids? Well, if we created a tetrahedron has 4 faces, but it's composed of 4 triangles. And if we look at this platonic solid, the base of 2 pyramids is a square in here. So what we have is we have 2 square pyramids which form this solid. So this platonic solid would be an octahedron which is composed of 2 pyramids. Problem 3. Which of the following types of triangles is shown above? Is it a scalene triangle, an equilateral triangle, a right triangle, or an isosceles triangle? What we want to help students identify here is that these are called tick marks. And in a tick mark, if there are a different number of ticks, that means that the sides are different. All right, so we know we can eliminate equilateral triangle because in an equilateral triangle, all 3 sides would be the same. So that means they would have the same number of markings on each side. So for example, if there was 1 tick mark here, there would be 1 tick mark here and 1 tick mark up on the top left. All right, so we know it's not an equilateral triangle. We know it's not a right triangle. In a right triangle, we're going to have 1 right angle, and the right angle would be marked with a little square in the corner if it was a right triangle. So it's not a right triangle. Also, it's not an isosceles triangle. In an isosceles triangle, at least 2 sides are the same. So we would have at least 2 tick marks that were the same along the sides. So in this case here, it has to be a scalene triangle. A scalene triangle has no sides the same. Problem 4. Set A is made up of all perfect squares less than 50. Set B is made up of all single-digit numbers. What is the intersection of sets A and B? All right, so when we're dealing with intersection of two sets, we're looking to see what the sets have in common. A set symbol is the opening and closing squiggly brackets here. The first thing we need to do is identify what set A is. So we need all of the perfect squares less than 50. All right, so let's do set A. So set A would be the perfect squares less than 50. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. 5 squared, 25, 6 squared, 36, and 7 squared is 49. So these are our perfect squares less than 50. Set B is made up of all single-digit numbers. So we're going to do 1 through 9. And for an intersection, we're looking to see what the two sets have in common. So I see here that I have the 1s in common, I have the 4s in common, and I have the 9s in common. So my answer would be this new set of combining or intersecting the two. So I would have an answer of the set 1, 4, and 9. That concludes our Praxis Elementary Education Mathematics Subtest 5003, Geometry and Measurement, Data, Statistics, and Probability. If you found this video helpful, please like and subscribe, and visit study.com, where you'll have access to more practice problems and personalized study plans. Thanks for watching.